did sample means. We started with sample proportions, then we did the difference of sample proportions. Then we did sample means, so now we're going to do the difference of sample means. But there is kind of a review of sample means in here, which is probably helpful because it's been so long since we've been here. I did. Thanks.
Sorry.
Anything else you want to interrupt with? Or? Okay. Alright, cool.
Do I need my calculator?
Yeah. Actually, yeah.
That's it.
Any other comments on my grooming or anything else? Okay. So, oh yeah, that's like a bad word to say. I didn't know that wasn't a word until like 5 years ago. It didn't mean that. Personal. Yeah, but personal. So, on top is just like notation. So you're gonna have two different means. So this is just like group 1 and group 2, and just going through notation. So remember, parameter is indicating the population, and that's either going to be mu1 or mu2, and it's going to be sigma1 or sigma2. And it might not even be 1 and 2, it could be like B and G for boys and girls, or S and J for seniors and juniors, but just like some indication that's different. Just remember that these symbols mean population. And then statistic is going to be X bar 1 and X bar 2. And then the standard deviation you can write two ways. You can write it as the standard deviation of X bar 1, sub and then sub again. Yeah.
I might be asking my question but are the mu and the standard deviation, like, do they mean mean and standard deviation right now? Or are they just symbols?
They do mean the standard deviation. What else would they mean? Okay. I don't know if you were
The
like.
way that you worded it, I just didn't feel like it connected.
Okay. The mean for population 1, standard deviation for population 1. Mean for population 2, standard deviation for population 2. And then the statistic is like the smaller version of the sample, remember? And you can write it as this like standard deviation of X bar 1, or sometimes you'll see S of X bar 1. That means the same thing. It's like the standard deviation of the sample. And then the same thing for the second one. So it could be sigma X bar 2 or S X 2. Yeah. Yeah, yeah. But if you just put it, it wouldn't be like a big deal. And then the sample size, like it's just going to be N1 and N2. Okay, so then, this is a little weird for me because I'm going through like her notes. So I'm kind of their way. So I screw up, that's probably why. But she says go back to sampling distribution of a sample mean, and then she gives reasons for the shape. We did the same thing. So if the population isn't normal, we know the shape is going to be okay as long as what? There are two ways to show this. Either the population is normal, or we have a sample size that is bigger than 30. Good. This is for one sample mean now, so we're going back. So a sample mean, the center of it, the center of X bar, the center of the sample mean, is going to equal mu. So if you all take a bunch of samples and we average them all together, that average will be the same as the population average, as long as what? As long as there's randomness, so it's unbiased. You know, if we're looking at like SAT score and we sample, not randomly sample, when we sample only AP students, that's not unbiased, and our mean wouldn't be the same as like the whole school's mean. And then the spread of population divided by the square root of n. And we could say that was true as long as close. As long as the sample is less than, because the population is the big picture there.
Yeah.
So as long as the sample, like our little sample n is less than or equal to 0.10 times big N capital. So like this is your sample. This is your population. So that's reviewing what we did. Were we in school one day last week? Yeah. One day last week, and then like Friday and Thursday before that or something. So now we're saying, okay, what if we have two means? Now we're going to have the difference between them. So it's still true that the population, if the population is normal, you're good. If the population is not normal, you need N1 to be greater than or equal to 30, and you need N2 to be greater than or equal to 30. For the center, we're always looking at the difference, so we're subtracting them. So the mean of x bar 1 minus x bar 2. This is the mean of the sample. This is like the difference in sample means. Is going to be equal to the population means subtracted also. So our sample means should be the same as the population means as long as what? Oh, I guess it says it right there. Yeah. It says two random samples right there. Random. And then the standard deviation, or the spread, this is the 10% condition, or independence. So the spread of the sample mean, the difference in the sample means. So this is the standard deviation of the difference in sample means. And you won't have to memorize this formula. Obviously, you know, I'll probably leave it on the board. It's basically just combining. It's really similar to the other one, but standard deviation of the first thing squared divided by the size of the first thing. Standard deviation of the second thing squared divided by the size of the second. I know this is all just like random notation right now. We'll do a problem in a second. Okay? I've heard it, right? Okay. Alright, so read through that problem there, and then let's try to figure out what they're asking and figure out what we're supposed to do. So I'm going to start labeling things. The mean height of 15-year-old boys is 175. So that's like the population data. So it's the population mu or x bar. Mu is like that U-shaped thing. That's the population. So I'm going to say like mu b equals 175. The mean of the boys is 175. And then the standard deviation of the boys is 8. And for girls, so I'll say mu g is 165. And the standard deviation of the girls is also 8. 8 boys and 8 girls were sampled, so NB equals 8, like the sample size of boys equals 8. My notation makes sense, like what I'm writing? Ish. Okay. And then so on I put here. NG equals 8 also, yeah. And then what I'm looking for, so probably the hardest part of this, what's the probability that the mean of the girls will be higher than the mean of the boys? So I want probability that, this is in my sample, this is my sample mean, so now it's not mu anymore, it's x bar. I want the probability that the x bar of boys is greater than the x bar of girls. I'm going to rewrite that in a second, but what's up? Yeah. Oh, my bad, thank you. Alright, so I have the probability that x bar girls is greater than x bar boys. Yeah, thank you. But like we want to look at, the way we look at it is the difference between them, we want to subtract them. So I want to rewrite this so it's one thing minus the other thing. So I'm going to subtract this from both sides, which will end up with girls minus boys is greater than what? 0. So this is what I'm after, which means I need to find the distribution of this thing, the x girls minus x boys. Alright, so I need the center, shape, and spread of those things. So the center of mean of x bar girls minus x bar boys. It's a random sample, so it's all unbiased and all should work out the same as the population. So the girls, if we do a bunch of samples and average them all together, what height should we get for all of the girls? 165. And what should we get for all the boys? 175. So this should be 165 minus 175, which is negative 10. And then to justify that, how do we know that that's true? Because they're both random. Because both samples are random. I need to know the shape, and then I need to know the spread, so I'll just write them all down first. The shape we're looking for, is it approximately normal or not? So is our sample distribution approximately normal or not? Well, I don't have a big enough sample size. I'm only at 8, so it's at 30. So I can't use the sample size. But what else do I know? It doesn't even frickin' say it, does it? What else am I looking for that I can't find out? Yeah, I want the population to be normal. It doesn't say it, so we're just going to say shape is approximately normal. Assume population for normal. It's kind of cheating, but it's okay for right now. And then the spread, I need to check that I have like at least, I have less than 10% of the population. So, you know, is 8 less than 10% of all boys? 15, yes. 8 less than equal to 10% of all girls that are 15? Yes. So because of that, then I can say the standard deviation of x bar girls minus x bar boys is kind of running out of room. So normally I would write the formula with letters and then with numbers. Is it okay if I just write it with numbers? So you take the standard deviation of the first thing, 8. Everything's freaking 8. This is kind of confusing. So it's going like this. Because they're all 8s, but like this is really the standard deviation for girls. And then the sample size for girls. And this is the standard deviation of boys. And then the sample size of boys. So let's figure out what that is. So go ahead and type that in. Make sure we all get the same thing there. You don't need pencils, I don't think. So I get 4, and you don't need parentheses. A lot of people try to put them in, which I think just confuses the issue. So I just want, you need like the very initial parentheses, but you don't need like sub parentheses. Yeah. You what? You know that like it automatically puts 1, doesn't it?
Like for some reason I did it this time, but usually I feel like I get it.
Mine didn't just this.
Wait, I'm just.
Like
It
it's
doesn't make sense.
like when you like my bar, like when I scan my
Oh, okay. So it's like an implied parenthesis. Okay. All I'm saying is people try to like put like parentheses around that and around that, and it just like messes people up. Okay. So what I know now, like after all of that, I'm looking for this info. Now I know this distribution is approximately normal. I know that because I kind of cheated and I'm assuming the populations are normal. But what is the, now I want to know the mean and the standard deviation of this distribution. So what's the mean of this distribution? -10, good. What's the standard deviation? 4. And now I want to know what's the probability that this distribution comes out greater than 0. So that's going to be, working in here now. That's going to be normal CDF. I know it's normal because I showed over here the population is normal. Yeah, I kind of cheated, but that's okay. And I want to be greater than 0. So I'm going from what to what? I want to be greater than 0. Greater than 0. So 0 to 9999. Then I tell the calculator the mean and standard deviation. What's the mean? -10. Standard deviation. 4. Type that in. Let's make sure we all get the same. I get 0.0062. Get the same? So this is the probability that if I took samples, that the average of the girls would be taller than the average of the boys. Makes sense. Like, it should be really small because boys are on average tall. So it should be pretty high. Is that a lot or was that not bad? A lot of hits. There are like 3 more. So should we do another one together? Okay. So read through that one. Okay, let's go through this. Oh wait, I want to change this first. You see where it says isn't 100 hours more than? Cross it out so to make it say is more than. Make sure you got that because it won't make any sense if you cross that out. Where it said isn't 100 more than, just cross it off so it says is more than. And then see, if you don't want to write it yet, because you don't want to be wrong, I get it, but see if you can like either write or say to yourself what those things are for this problem. I'm going to call it like A and B. it's like light out. Oh yeah, when is that? March something. Is it? Really? Spring ahead, yeah. Spring forward.
So is
Really
it gonna
hours.
get later or forward? It's spring.
It's always-
spring.
I thought it was always.
I know.
Spring is on the 21st, but you don't know what's spring forward.
Oh, that's great.
I don't think so. I would love that, but
Oh,
like I always hear like there's a bill in Congress to like get rid of it, but it never.
Yes, it's Sunday, March 12th. It's not a thing in our
It doesn't need to be a thing here.
It's not a thing in Arizona. So
Oh, yeah.
like, yeah, it's
Oh,
Arizona.
really?
So they're 1 hour away, like part of the year. They're 2.
So
No,
like
they're 2 hours away.
there's more car accidents any day that day, the
Yeah.
day after, than any other day of the year. And there's more suicides that day than any day of the year, except for Christmas.
Wait, what day?
The day after because everyone like loses sleep. So people are tired and miserable. The day after spring
So they-
forward.
Oh.
So they just commit suicide?
Not like everyone. I'm saying like if you were prone to it. Not just and car accidents because all the driving. Rocky and that thing.
Shouldn't be right there.
It's like, okay. So I want to know the mean of population A. That's 2,500. Standard deviation of population A is 500. And then I'm just kind of reading through a little forward. N1 is 300. And then take a sample of 300. And A. Thank you. The mean of population B is 2,300. Standard deviation of population B is 800. And then sample size of population B is 200. Agree with those? Okay. So the next, see if you can tell me what we're looking for. What I mean by that is figure out like this part here. Like we're looking for the probability that 1 is greater than 1, which means what minus 1 is greater than 0.
X bar A is greater than X bar B, and then X bar A minus X bar B is greater than.
Yes. Yes. You got any movies you want to spoil the ending to too? Like,
Oh, no, I thought.
I'm just kidding. I'm kidding. So we want to know the probability that X bar A, so the sample of A, is more than or greater than the average, the sample of B, so X bar. But then I don't think about it that way. I think about the difference. So like she said, I want to subtract them, and I want X bar A minus X bar B to be greater than 0. Alright? Questions on like that's just kind of like the setup. Okay? Alright, so now I need the center, shape, and spread. So the center is going to be the mean of A minus the mean of B, which is 2,500 minus 2,300, which is 200. How do I know that is okay to use? I don't think it says it.
We assume.
Yeah, so we're going to have to assume, what are we assuming? Assume SRS. Make sure you put for both, because there are 2 samples, so we have to make sure that both SRSs.
Wait, so for like the order of how you do it, so like A minus B, is that just like the order that it is, in like,
In the wording.
in the wording?
So that's how I got to there. Because it said A has to be greater than B.
Yeah, so like, is that how
first. So, wait, were you asking the same? Or?
I think that's.
So, do you understand how I got to that?
Oh yeah.
Okay. So then, all my calculations are in terms of like A minus B or B minus A. I have to be subtracting.
Okay.
So I'm just rewriting this. Like basically, I'm subtracting this from both sides. So it like cancels over there, and then I end up with this and this.
Yeah. So then for like the center, it's A minus B. So that's
Because of this order right here.
yeah.
But if it was like B minus A, it would be B minus A down.
Yeah. So whatever order you have right here, you do over here also. You guys are good. Okay, shape. Basically always going to be approximately normal because I want you to do the thing. But how do we know in this time? Both samples are greater than 30, right? We have like 200 and 300. So again, make sure you say for both when you have two samples to think about. And then the spread. So I've kind of got to assume that 300 is less than or equal to 0.10 of like all A appliances. And 200 is less than or equal to 0.1 times all B appliances. You guys see where I'm getting that from? Okay. And then I have room this time. So my standard deviation of x bar A minus x bar B is standard deviation of A squared over NA plus the standard deviation of B squared over NB. So go ahead and plug in numbers there, figure out standard deviation, and let's make sure we're all in agreement. $63.5? Yeah. Okay, so the standard deviation of A is 500. And then the sample size of A is the 300. You okay? The sample size of B is, I'm sorry, the standard deviation of B is 800. Did you guys get 63.5? Okay. No, that's fine. No one said yes, so I figured, I thought I was missing something. You're good. And then go ahead and see if you can answer the question. If you're like caught up here. Did anybody think there was like a chance of this going in? It was supposed to be like freezing rain. The middle of the night. That would have been something. I didn't expect any of the studies we had this week. Like every single time I was reading power. Yeah. How many of you guys lost power?
just last night. Mine came
Still
back a
have
couple
not.
days ago.
I live in Gibson.
Addie was on power school.
Really?
Yeah.
It's cold. Still whatever.
Oh, I think it was today. We're supposed to get it back. I don't know.
Sucks.
I don't know how it's going.
Really? Well, then I read like heard that no one can find hotels because like everyone's doing that. Okay, so I want to know the probability that we're greater than 0. So that tells me 0 to 9999. Then I tell the calculator the mean and the standard deviation. So it might be helpful to kind of write this, like that version of this, sort of out of room, and it would be approximately normal with a mean of 200 and a standard deviation of 63.5. And you don't have to write that. It just might help you like identify what goes here. Then you tell the calculator the mean and standard deviation, which is those two numbers. Did you get 0.999? Alright, so it's pretty likely.
I have a question.
Yeah.
How did you know you were supposed to use 0.999?
From this. Because I want x a minus b to end up being greater than 0.
Okay.
So I want it positive. Which is, if it was less than 0, I would have put negative 999 to 0.
Okay.
Good? Yeah.
Yeah, because just reading the question, like it says like company A like is more than the average like
Well.
sample from company B. So I thought that like the low would be like the samples from company B. So like 2300. That's just how.
So the mean, you gotta combine them. So the mean is, they're saying, let's forget like the x bar and all that stuff. They're saying we want a to be greater than b. Right? Isn't that the same as a minus b is greater than 0? And so the mean of a minus b, you just like do 2500 minus 2300, and that was 200. And the standard deviation was the blah blah blah. So then, like ignore all the rest of the stuff. What you have now is we're looking for this greater than 0, and that's the mean, and that's the standard deviation. So greater than 0 is where I got the 0 in. So this is always going to be either a minus b or whatever it is. It's greater than 0 or less than 0. So this will always be 0 to 9999 or negative 999 to 0.
Okay, so
Okay. The absences in first grade?
Yeah, like, are we doing the at most 3 things? Or
No. So let's do that. So cross off at most 3. So yeah, I want you guys to try this one. And make sure you cross out the at most 3. Yeah.
So when you want, like,
Normal or
yeah,
random or
yes.
whatever, you just assume. Yeah. And the multiple choice would be more like, they give you an option that's like, we don't have enough information, you would choose that. But then they want you to like do it. Kind of doing it with you, so if you want to check as you go and something, and want to do it all and check after, that's all good also. set up by validating. I didn't do the answer yet, but this is the work for it. Yes, we're not going to get to number 4. Jeez. You guys get basically 1? Yeah. That's basically 1.9999997. I'll put approximately 1. I mean, that makes sense. Boys have approximately 5 more absences than average, so they're probably almost always going to be graded. Question on anything I set up here? The answer, any of the reasons I justify anything? So when you come in tomorrow, I'll have you start with number 2. So you remember anything we did today, and then we'll go from there. Yeah. So Friday's a half day? I don't know if you guys do that. But yeah. So
Wow, look at that. Just never
probably Thursday.
It's Thursday?
Yeah. For the test.
And it's over proportional.
Wow.
If you're, yeah, it's
Like that
already.
whole thing.
So like we took a quiz on these 2, then we learned these 2, you test on all 4. But I'll make sure you have reviews for all that stuff.
Is it a morning half day or an afternoon?
I don't know